Hi everyone, my name is Farahin Zain. One of the requirements for the Advanced Foundation Engineering, I have to make a video of how I utilize SoilVision. SoilVision is a software that provides comprehensive suite of 2D and 3D geotechnical related. As for my project, I chose to do a SVSlope to dig weak layer geotechnical modeling. I use the example and data from tutorial in the software. First, we have to create a model by using learning mode. We can start with new model and enter the details needed. Next, we have to specify analysis settings. For this example, I enter the details such as slip direction, slip shape, search method which is block, and the calculation methods I used GLE Fredland. Then we have to enter the geometry. There are a few methods in how we can enter the geometry, such as drawing from CAD, dynamic import, cut and paste, and import geometry from existing model. As for the example, I chose cut and paste method, which is from the data given. I just copy it and paste it into the software. As you can see in the screen, it is actually the created of first region, and then there's the second region, which is the weak layer, and the next step is actually creating the third region, which is lower region. And it will look exactly like in the screen, where there's definitely 3 regions created. So for the next step, actually we have to apply materials properties. In this example, there are 2 types of soil, and both of it were using method more column method. And the upper region, we classified it as soil 1, and then the middle region, which is weak layer, we classified it as soil 2, and the lower regions was also assigned as soil 1. After we assign the type of soil to the region, then we can click OK. So if you can see in the screen, there are already 2 different colors, which is different the type of soil for upper, lower, and middle layer. So next is the step for the slips, which is in slip, we have to create 2 lines in order to specify such method geometry as shown in the diagram. If you can see, there are definitely 2 lines already shown. And the next step for this example is that we have to specify pour water. For the pour water, we selected the water surface and use the piezometric lines to create it. And it will look like exactly in the screen. After that, we have to specify the loading condition. They are the next step after we specify the bore water. To specify the loading condition, we are going to click on the tab, loading tab, and chose distributed load. For this project, we chose distributed load, and then we create a new button, and we set the loading. When we set the loading, we have to select the point where the load will lays. To select the loading, there are two types, which is constant type and trapezoid type. We have to do the constant type first, and then we have to enter the acting load, and after that we have to select point, which is the X and Y, and after that we have to create new button for the lower left hand corner of in the screen. For the trapezoid type, and we enter just the same step. We enter the acting points section and the point load, and then after that we can click OK. So in this example, we have two kind of distributed load, for the constant type and for the trapezoid type. And after the distributed load has been shown, the next step is that we have to analyze the model. To analyze the model, we have to choose analyze bar. We have to click the solve tab, and then we have to analyze. This step is very simple, which is when the dialog box pops up and asks if we want to save and continue the model, just click OK. So the project will be saved and we can continue, and the SVSlope solver will automatically solve our slope modeling, and right after we can view the result. As for the result, we can click the visual result to the current model and selecting solve result interruption. The model result will be displayed later. So if you can see, this is the visual result of my project example, and my FOS is 1.411. So that is the very simple summarization for SoilVision by me. Thank you.